Imagine a place so deep that Mount Everest could sink into it and still not touch the surface. A place darker than space, colder than Antarctica, and under pressure so intense it would crush a human body in an instant. This place is real. It exists on our planet. And it's called the Mariana Trench, the deepest known point on Earth. For decades, scientists believed this abyss was empty, lifeless, a silent dead zone at the very edge of our world. But they were wrong, because when we finally reached the bottom, we didn't find anything. We found life. We found pollution. We found entire ecosystems thriving where nothing should survive. And what we're still uncovering down there may completely change how we understand life on Earth and possibly life beyond it. So before we begin this descent into the deepest place ever explored, take a moment to subscribe to the Deeplogy. And if this journey into the unknown fascinates you, make sure to like and share this video so more people can explore the depths with us. Tonight, we're going deeper than almost any human ever has, to uncover what was really found at the bottom of the Mariana Trench. The deepest place on Earth. The Mariana Trench lies in the western Pacific Ocean, east of the Philippines, hidden beneath some of the most remote waters on Earth. It stretches for more than 2,500 kilometers, longer than the Grand Canyon, and plunges nearly 11 kilometers straight down into the planet's crust. This is not just a deep place. It is the deepest place we know of, a vast scar in the Earth where the seafloor collapses into darkness. At its lowest point, known as Challenger Deep, the environment becomes so extreme that the rules of the surface world no longer apply. At Challenger Deep, the pressure exceeds 1,000 times what we experience at sea level. Under these conditions, a human body would be crushed instantly, steel-hulled submarines would collapse like paper, and even modern deep-sea technology struggles to survive. For most of human history, this crushing abyss was completely unreachable, existing only as a mystery hinted at by sailors and scientists who could only guess what lay below. In 1875, that mystery deepened when the British research vessel HMS Challenger lowered a weighted rope into the Pacific Ocean. The crew waited as the line disappeared into the depths, longer and longer than anyone expected. When it finally touched bottom, scientists were stunned. The ocean was far deeper than previously believed, revealing that Earth still held vast, unexplored frontiers. And yet, this discovery was only the beginning of what the Mariana Trench would eventually reveal. The first visitors. For nearly a century after the HMS Challenger's discovery, the deepest part of the ocean remained untouched by human hands. Then, in January of 1960, two men changed that forever. Jacques Piccard, a Swiss oceanographer, and Don Walsh, a U.S. Navy lieutenant, descended into the Mariana Trench aboard a small steel bathyscaphe called Trieste. For almost 5 hours, they sank through complete darkness, listening to the hull creak under pressure as the ocean above stacked itself mile by mile. When Trieste finally reached the seafloor of Challenger Deep, nearly 11,000 meters below the surface, the impossible seemed to happen. Through a small viewing port, Piccard reported seeing a flatfish-like creature glide across the sediment, alive and unbothered by the crushing pressure. At the time, this observation shocked the scientific community. Many experts believed vertebrate life simply could not survive under such extreme conditions, and the sighting was quietly questioned. For decades, Piccard's claim lingered in uncertainty. But as technology improved and unmanned vehicles returned with clearer footage, scientists were forced to reconsider. Later discoveries of deep-sea fish living at extraordinary depths confirmed what once seemed impossible. Piccard had not imagined life at the bottom of the world he had witnessed, and with that realization, the Mariana Trench transformed from a lifeless void into a frontier filled with unanswered questions. Life where life shouldn't exist. For much of modern science, the deepest parts of the ocean were assumed to be sterile, a place where life simply could not exist. Without sunlight to power photosynthesis, with temperatures hovering near freezing and pressure intense enough to warp metal, the Mariana Trench was believed to be biologically silent. It was thought of as a graveyard of sinking debris, not a living ecosystem. That assumption would not survive contact with modern exploration. When robotic landers and sampling devices finally brought sediment back from the trench floor, scientists were stunned. The mud was alive with microorganisms and thousands of microbial species, many of them completely unknown to science. These microbes had evolved to feed on chemicals like methane and sulfur instead of sunlight, and many did not require oxygen at all. Their cells contained specialized mechanisms that constantly repair DNA damaged by extreme pressure, allowing them not just to survive, but to function normally in an environment once thought uninhabitable. What surprised researchers most was the scale of this hidden world. Genetic studies suggest that the microbes already identified may represent only a fraction of what actually lives in the trench. Far from being lifeless, the deepest ocean appears to host one of the most extreme and least understood ecosystems on Earth. Chapter 4. The animals of the Hadal zone. The deepest layer of the ocean is known as the Hadal zone, named after Hades, the underworld of Greek mythology, and it is an environment that feels true to its name. Here, the seafloor is locked in perpetual darkness, and the pressure is so intense that survival requires extreme specialization. Yet even in this hostile realm, animals move slowly across the sediment, adapted to conditions that would instantly destroy most life on Earth. Among the most common inhabitants are amphipods, small shrimp-like scavengers that roam the trench floor in search of organic matter drifting down from the surface. Some Hadal amphipods grow far larger than their shallow water relatives, protected by reinforced exoskeletons and powered by enzymes that continue to function under crushing pressure. These animals play a vital role, recycling dead material and sustaining the deep-sea food web in a place where new energy is scarce. Higher up the trench walls, scientists encountered the deepest living fish ever recorded, the Hadal snailfish. Living at depths beyond 8,000 meters, these fish survive thanks to soft, gelatinous bodies, the absence of air-filled swim bladders, and unique proteins that protect their cells from pressure damage. Beyond this depth, vertebrate life disappears entirely, leaving only invertebrates to inhabit the deepest reaches of the ocean. Chapter 5. Giant single-celled life. Among the most unexpected discoveries in the deepest ocean was a form of life so strange that it challenged basic assumptions about what a single cell can be. Scattered across the trench floor, scientists found xenophyophores organisms that look more like fragile coral or alien architecture than anything alive. Yet each one is not a colony, not a plant, and not an animal. It is a single cell, expanded to a size large enough to be seen without a microscope, thriving in total darkness under immense pressure. Xenophyophores survive by slowly collecting particles from the surrounding sediment, building intricate shell-like structures from minerals and organic debris. These structures sprawl across the seafloor, forming delicate networks that appear almost architectural in design. In the stillness of the Hadal zone, where energy is scarce and movement is minimal, these organisms grow patiently over long periods of time, shaped by pressure and isolation rather than speed or competition. What makes xenophyophores truly remarkable is not just their size, but their impact on the environment around them. Their complex shells create shelter for smaller organisms, offering protection in a place where hiding spots are rare. Worms, crustaceans, and microbes take refuge within these structures, turning a single cell into the foundation of a small ecosystem. In the deepest parts of the ocean, where life is thinly spread and survival is uncertain, xenophyophores act as quiet architects, shaping the landscape and supporting life far beyond themselves. Chapter 6. Life without sunlight. In the depths of the Mariana Trench, sunlight is not just absent, it is irrelevant. No ray of light has ever touched this world, and yet life persists. For a long time, this reality puzzled scientists because nearly all life on Earth ultimately depends on the sun. Plants capture sunlight, animals eat plants, and energy flows downward. But in the deepest ocean, that familiar chain is broken. Life here follows a completely different rulebook. The key to survival in this lightless realm is chemosynthesis. Instead of drawing energy from sunlight, certain microorganisms extract energy from chemical reactions occurring naturally within the Earth. Compounds like methane and hydrogen sulfide seep up from the seafloor through cracks and sediments, and specialized microbes use these chemicals as fuel. These organisms form the foundation of food webs that exist entirely independent of the sun, quietly converting chemistry into life in total darkness. This discovery reshaped biology. It proved that sunlight is not a requirement for life, only energy is. The realization forced scientists to rethink where life might exist, not just on Earth, but beyond it. If organisms can survive miles beneath the ocean by feeding on chemical energy alone, then similar ecosystems could exist beneath the icy shells of distant moons like Europa or Enceladus. In the crushing darkness of the Mariana Trench, life revealed a truth with cosmic implications. The universe may be far more alive than we once believed. Chapter 7. Viruses at the Edge of Life. Even in the crushing darkness of the Hadal zone, life finds a way, and that includes viruses. For decades, scientists assumed that viruses, the smallest and simplest biological entities, would be absent from the extreme depths of the ocean. Yet, recent expeditions have shown that viruses thrive even at depths exceeding 8,800 meters, making them the deepest viruses ever discovered. These tiny entities may seem insignificant, but they play a crucial role in the deep sea ecosystem. These deep sea viruses infect the pressure-adapted bacteria that form the foundation of Hadal food webs, regulating populations and influencing nutrient cycles in ways that scientists are only beginning to understand. Their presence proves an unsettling yet remarkable truth. Even in the most extreme, isolated, and inhospitable environments on Earth, ecosystems are dynamic, balanced, and interconnected. Nothing in the Mariana Trench exists in total isolation. The viruses, microbes, and larger animals all interact, forming a delicate web of survival in a place where life was once thought impossible. In the depths of the trench, even the smallest organisms remind us that the planet's ecosystems extend far beyond the surface, and that empty space is rarely, if ever, truly empty. Chapter 8. The Darkest Discovery. As exploration of the Mariana Trench continued, scientists were prepared for surprises, the strange life forms, the crushing pressure, the alien chemistry of the Hadal zone, but they were not prepared for what came next. During a series of deep-sea expeditions, robotic landers and cameras captured something alarming at nearly 11 kilometers beneath the surface: human trash. At the bottom of the world, in a place so remote that sunlight never reaches, researchers found plastic bags, fragments of packaging, and microplastics scattered across the seafloor. Even the smallest sediments carried traces of chemical pollutants, a stark reminder that no corner of Earth remains untouched by human activity. This revelation was both shocking and heartbreaking. Deep-sea creatures, including amphipods and other invertebrates, were found with tiny particles of plastic inside their bodies, unknowingly consuming the debris humans had produced. These pollutants are not superficial. They have persisted in the trench for years, preserved under the immense pressure and cold of the Hadal zone. Even the Mariana Trench, a place once thought completely removed from human influence, now serves as a silent archive of our impact on the planet. Researchers realized that the reach of human activity extends far beyond cities, far beyond the surface oceans, and into the very depths that seemed eternal and untouchable. This discovery forces a confrontation with the consequences of our consumption and waste. It illustrates that the materials we discard eventually cycle through ecosystems, reaching places so remote that they were once considered pristine. The Mariana Trench, long a symbol of Earth's final frontier, has become a mirror reflecting the pervasive spread of pollution. Even in the crushing darkness, life struggles to survive, and yet it now carries with it the tangible legacy of human civilization. This is a sobering lesson. The deepest and most isolated places on Earth are not immune to the consequences of our actions, and the trenches are a stark warning of how far our footprint has traveled. Chapter 9: What We Haven't Found Yet. Even after decades of exploration, the Mariana Trench remains one of the least understood places on Earth. Scientists who have descended into its depths or studied samples from the seafloor know they have only scratched the surface. Most of the species living in the trench are likely still undiscovered, hidden in the inky darkness under crushing pressure. Every expedition brings back organisms that challenge what we thought we knew about life on Earth, and each new discovery raises more questions than it answers. Beyond the animals and microbes we have already documented, researchers suspect that entirely new chemical processes are occurring in the trench, unlike anything seen at shallower depths. These processes may form the foundation for life in ways we have yet to understand, potentially supporting organisms that thrive entirely on chemistry extracted from the Earth's crust, methane seeps, and hydrothermal activity. Some of these reactions could even operate under pressure and temperatures that would destroy surface organisms, revealing ecosystems functioning on principles almost alien to the familiar world above. Entire microhabitats remain unmapped, hiding pockets of life tucked between rock formations, sediment layers, and hydrothermal vents. The trench is not a flat abyss. It is a jagged, mountainous landscape with ridges, valleys, and cliffs that create isolated ecological niches. Some of these niches may host unique species that exist nowhere else on Earth. Advanced robotic exploration and environmental DNA sampling are only beginning to reveal the trench's staggering complexity. Chapter 10: Why This Matters Beyond Earth. The Mariana Trench is more than just the deepest part of our oceans. Its extreme environment, crushing pressure, total darkness, near-freezing temperatures, and life fueled by chemistry instead of sunlight offers a glimpse into what alien worlds might be like. Moons in our solar system, such as Europa orbiting Jupiter, Enceladus around Saturn, and Titan, are believed to harbor deep oceans beneath thick layers of ice. If organisms can survive in the crushing depths of the Mariana Trench, feeding on chemical energy and thriving without sunlight, it suggests that life could also exist in these hidden extraterrestrial oceans. Studying the trench gives scientists a living laboratory to understand the limits of life, informing the search for life beyond Earth, and showing that where there is energy, even in the harshest conditions, life may find a way. Chapter 11: The Future of Exploration. The future of Mariana Trench exploration lies not in human divers, but in machines built to endure the crushing depths that would destroy any person. Autonomous robots are now descending into the Hadal zone, mapping the seafloor in unprecedented detail, collecting samples, and capturing high-resolution images of life that no human could safely observe. Long-term deep-sea landers are being deployed to sit on the ocean floor for weeks or months at a time, monitoring environmental conditions and documenting the daily rhythms of trench ecosystems. Environmental DNA sampling allows scientists to detect species without ever seeing them, revealing hidden life through genetic traces suspended in the water or trapped in sediments. Alongside these innovations, high-pressure laboratory simulations on the surface recreate trench conditions, helping researchers study organisms in ways that were impossible just a few decades ago. Humans may rarely visit these extreme depths again, but machines will continue the descent, uncovering the secrets of life at the bottom of the ocean. Every discovery brings us closer to understanding not just the Mariana Trench, but the limits of life on Earth and beyond. We didn't find sea monsters. We didn't find lost civilizations or treasures hidden in the darkness. What we found was something far more extraordinary, something that challenges how we see life itself. In the crushing, freezing depths of the Mariana Trench, life not only survives, it thrives. Microbes repair their DNA under pressures that would annihilate surface creatures. Amphipods scavenge the ocean floor, snailfish navigate the abyss without sunlight, and single-celled xenophyophores build entire ecosystems with nothing more than sediment and minerals. Even viruses, invisible to the naked eye, orchestrate delicate balances that keep these extreme communities alive. This is proof that life adapts, that ecosystems persist where we least expect them, that even in the darkest, most remote corners of our planet, everything is connected, including us. And yet, the trench also reflects a harsher truth. Human influence reaches further than we often realize. Plastics and pollutants, even here, remind us that no place is truly untouched. The Mariana Trench isn't the edge of the world. It's a mirror, showing both the resilience of life and the scope of our impact. So as we close this journey into the Hadal depths, take a moment to rethink certainty. Let curiosity guide you, not fear. If this cosmic mind-blower amazed you, like this video, share it, and comment below with your favorite discovery from the deep. And don't forget to subscribe to Deeplogy to explore more mysteries of our planet and beyond. The ocean's depths may be dark, but the story of life is brighter than we ever imagined.